What if the water you drink, the oceans that cover our planet, and even the tears you cry are all secret interpreters of light? Imagine an element that doesn't just reflect or scatter light, but learns its language, bending, splitting, dancing, and preserving it with endless nuance. In this episode, we're exploring the profound dance between light and water, and how together they paint nearly every vision of beauty this planet knows. No element answers light as intimately as water. Air may scatter it, and stone may reflect it, but only water learns its language, bending, splitting, dancing, preserving. From the shimmer of a pond to the blaze of a rainbow, water interprets sunlight with endless nuance. Together, they create nearly every vision of beauty this planet knows. Where light meets water, the world learns to sparkle. Look at any lake on a calm morning, and you witness nature's oldest mirror. Incoming solar rays strike the surface. Some penetrate, and some return. When the angle of incidence equals the angle of reflection, about 30 degrees for most viewing, the surface becomes glass. Each photon ricochets with perfect symmetry, reconstructing sky and mountain upside down. The stiller the surface, the clearer the image. The slightest ripple fractures it into impressionistic fragments. Claude Monet painted these tremors endlessly, seeing in them the dialogue between form and flux. Reflection is more than poetry. It is physics of boundary. At the interface between air, optical density and approximately 1.00, and water and approximately 1.33, roughly 2% of visible light reflects even when viewed head-on. The rest refracts inward. As the angle grows shallower, reflection intensifies, reaching 100% at the so-called critical angle. This variable brightness explains why sunrise mirrored in a lake looks aflame, while overhead sun does not. The lower angle favors reflection, the higher penetrates. Thus the world's brightness depends as much on one geometry as on one star. Passing from air into water, light slows, and with that slowing it bends. This refraction follows Snell's law. N sub 1 sin theta sub 1 equals n sub 2 sin theta sub 2. The change in velocity from c approximately 3 times 10 to the 8th meters per second to 0.75 c in water tilts the ray toward the normal compressing vision beneath the surface. To a swimmer looking upward, the outside world shrinks into a circular window 96 degrees wide, the Snell's window. Beyond that boundary, light reflects internally, trapping the underwater view in perpetual dome. Divers photograph this window as a halo of day framed by darkness, proof that every perception depends on refracted boundaries. Fish, living entirely within this optical logic, see differently. Their world is both brighter and smaller. Refraction also magnifies life above water. A stick plunged into a pond appears bent or broken because returning rays exit at larger angles than they entered. If you're finding this exploration of light's watery dance as captivating as we are, consider hitting that subscribe button and joining us for more journeys into the universe's incredible phenomena. In that distortion, the human eye learns an ancient truth. Nothing seen through fluid is simply what it appears to be. Light does not traverse water evenly. Red wavelengths, 700 nanometers long, vanish within the first 5 meters. Yellow fades by 30. Green persists to 100. Blue alone reaches 250 meters. Below that depth, the oceanic twilight zone, darkness reigns, punctuated only by bioluminescence. Because shorter wavelengths penetrate best, oceans look blue from space. But where sediments or plankton absorb and scatter differently, seas turn turquoise, jade, or brown. Each hue tells a story about life and matter suspended in light. Phytoplankton, rich in chlorophyll, absorb red and blue while reflecting green, a color more diagnostic than ornamental. Satellites map such tones to measure biological productivity, translating the ocean's chromatic whispers into equations of health. When wind strokes water, waves become prisms. Each crest and trough alters reflection angles, remixing brightness into glitter. The phenomenon we call sparkle occurs when specular reflections from countless microfacets momentarily align with our eyes. Every gleam is a single photon's perfect coincidence, a reminder that beauty can be statistical. Artists and sailors read these glints differently. Painters chase them for texture. Navigators use them to gauge wind. Physicists call the pattern sun glint, mapping it globally with satellites to infer ocean roughness. Even chaos has rhythm when seen in light. When sunlight enters a spherical raindrop, it reflects internally once, and exits, the angles between red and violet separated by 2 degrees. Because billions of droplets perform the same geometry, observers see a collective arc, the rainbow. Each color emerges at a consistent deviation, red at 42 degrees, violet near 40. The relationship between droplet and observer determines position. The bow moves with the viewer, never fixed in space. Occasionally, twin reflections inside droplets create a double rainbow with a fainter outer arc reversed in order. Between them lies the dark band of Alexander's shadow, where no rays exit, a dynamic partnership of presence and absence. Every rainbow thus encodes 2 paradoxes. It is both universal and individual, real and intangible. Walk toward it and it retreats like wisdom tested by pursuit. Water translates light into motion through reflection and refraction alike. On shallow sandy seafloors, ripples act as lenses focusing sunlight into shifting bands called caustics. They dance across coral and shell, optical fingerprints of wave motion. Mathematically identical patterns appear in coffee cups, swimming pools, and the interiors of cathedrals where sunlight passes through wavy glass. The same equations describe the paths of galaxies bent by gravity, a cosmic echo of seaside shimmer. To gaze into rippling water is therefore to watch relativity in miniature. Space bending, light following curvature, perception fluid yet exact. When light enters clouds of suspended droplets smaller than 50 micrometers, scattering becomes nearly uniform for all wavelengths, a phenomenon called non-selective scattering. Fog thus appears white or grey, enveloping color. Within it, brightness loses direction. Everything glows evenly. Painters of early morning know this softness, the vanishing of shadow, the surrender of detail. It is the opposite of glare, illumination without orientation, light democratized. At dawn, mist along a river filters the first rays into creamy diffusion. The sun seems larger, safer. For brief moments, anyone can look directly at it, its power transmuted by water's compassion. Solid water also speaks fluent optics. Snow's whiteness arises from myriad internal reflections among ice grains. Individual flakes, clear as glass, collectively behave as mirrors pointing every which way, an orchestra of prisms scattering all wavelengths together. In polar regions, sunlight refracting through hexagonal ice crystals in cirrostratus clouds creates halos 22 degrees wide, a spectrum ring encircling the sun or moon. When light passes twice through differently oriented crystals, brilliant crosses and arcs appear, parhelia or sundogs, loyal companions of winter brightness. Glaciers and deep ice, compressed and impurity-free, filter long wavelengths as water does, glowing blue from within. Walk through an ice cave and you traverse condensed daylight, a cathedral carved by time and temperature, lit by physics alone. Beneath the ocean's surface, where sunlight dwindles, life creates its own radiance. Bioluminescent organisms, jellyfish, anglerfish, plankton, convert chemical energy into blue-green glow. luciferin molecules oxidize, releasing photons efficiently enough to outshine the dim sunlit trickle. To predators and mates alike, these flashes are communication, camouflage, or lure, language written in living light. When swells disturb bioluminescent plankton near shore, entire waves ignite turquoise, each curl a glowing handwriting across the night sea. For those who witness it, the experience feels metaphysical, light seemingly reborn from its own extinction. But if water can bend and scatter light into such breathtaking displays on the surface, what hidden wonders lie beneath, where sunlight dwindles to nothing? What if life itself has learned to create its own light, painting the abyssal darkness with a language of living glow? In recent decades, scientists have adapted these proteins as markers in genetics. Every glowing cell in a laboratory petri dish carries a lineage traced to marine brilliance. Life under pressure still guides discovery under microscope, a continuity across scales. Beyond artistry, water modulates climate by reflecting and absorbing light. Globally, oceans absorb about 93% of solar energy reaching them, redistributing heat via currents. In contrast, ice and clouds reflect much of it, contributing to Earth's albedo, roughly 30% overall. Melt too much ice, and reflectivity drops, accelerating warming. Freeze more, and the planet brightens, inviting cold. Thus, every sheen on every lake participates in thermal balance. Shimmer is stewardship writ small. Clouds themselves recycle sunlight, bouncing half of what hits them back to space. At sunset, their height and thickness decide palette. Thin cirrus catching scarlet, thick stratus dulling it to slate. Weather is art performed by light on airborne water. Rivers dazzle differently than seas. Their currents, broken by stones and bubbles, scatter light chaotically, producing white water whose color stems from trapped air, not water itself. When bubbles vanish and sediments settle, gentle backscatter paints rivers green or brown according to minerals carried, iron yielding red, limestone turquoise. Each hue is a record of journey, a diary of terrain written in optics. At waterfalls, mist refracts sunlight into signatures unique to every cascade. Niagara's persistent bow, Iceland's double arcs appearing in horizontal spray, Victoria Falls by moonlight producing lunar rainbows. All emerge from the same physics, but write different moods. Water acting again as translator of brilliance into emotion. Rain changes not only sight, but sound and scent. Falling droplets scatter acoustic waves, softening landscapes. Their slower counterpart in optics, diffuse reflection, dulls edges of color. Surfaces darken because wetness lowers reflectivity, reducing scattered light. Every raindrop thus deepens hue. Red bricks richer, green leaves glossier. After rainfall, when the sun returns, specular highlights, sharp as jewels, reveal the planet freshly lacquered, a temporary perfection polished by weather. The scent we call petrichor is chemistry's echo of this meeting between water and dust. Light's brightness, rain's perfume, two senses describing renewal with different vocabularies. Humanity learned optics by observing water before glass. Ancient scribes used curved bowls of liquid to magnify text. Arab scholars in the 10th century described how refraction in spherical vials could focus images, proto-lenses foreshadowing telescopes. Even today, liquid lenses exploit droplet curvature to adjust focus by surface tension alone. In every device that gathers light, from cameras to telescopes, water's principles persist. Scientists reading starlight through the oceans of air above use similar equations. Every observatory compensates for atmospheric seeing, as though peering through a planetary aquarium. In studying the cosmos, we inevitably study the optics of water. Cultural traditions have always linked water's brightness with purity and rebirth. Ritual baths, baptisms, ablutions, all transform physical cleansing into symbolic reflection. The mirror of water doubles worlds, heaven above, reflection below, a symmetry so perfect that countless temples and mosques frame pools precisely to capture sky. Pilgrims who gaze into them read not vanity, but connection. To see one's face joined with clouds is to remember the body's kinship with vapor and light. Stand beside a river at sunset and notice. Each ripple carries a miniature sky. Photons that left the sun 8 minutes ago scatter among molecules older than life, divide, rebuild, and leap toward your eyes as fleeting gold. To the universe, they are statistics. To you, vision. Through water, light discovers memory, able to reflect, refract, and return. And in those returning glimmers lies reassurance that nothing in nature truly disappears. It only changes direction. Water, keeper of reflection, is the planet's consciousness of light. Without it, Earth would be silent blue stones spinning in blackness. With it, the world trembles into color, and the sun sees itself smiling back. If you've been enlightened by the profound dance between light and water, make sure to subscribe for more incredible journeys through the cosmos. And to continue your exploration of the universe's wonders, click on the video appearing on your screen right now.